Hello students, class 12. Let us continue the same topic, inverse trigonometric functions. Today we will discuss properties of inverse trigonometric functions. Let us discuss first property in which what we are writing sine inverse of sine x equal to sine of sine inverse x. How we can write it? You can see proof. Let us discuss first part of it, and which is we are taking y as sine x. And already you know, in this function, if we will write in the form of inverse function, we can write like this: sine inverse y equal to x, and y is sine x. That's why we have replaced y as sine x. It means what we are getting, sine inverse of sine x is x. Similarly, we can prove the second part of it, and it is we are taking sine inverse x as z. Let us change inverse function. Let us shift sine inverse as sine of z is equal to x, and z is replaced as sine inverse x. Therefore, what we are getting, sine of sine inverse x is x. In both the cases, what we are getting, sine inverse of sine x is x and sine of sine inverse x. It means if the functions are same, these two functions, one is inverse, other is not inverse, that's what we are getting. We are getting only the whatever we have in the form of either variable or anything, whatever we are having, that is left here. Now this is first property. What about the second one? Sine inverse x equal to cosec inverse 1 by x. Here what we can do, for proving it, we can consider either LHS as y or RHS as y. So what I am taking here, LHS sine inverse x as y. Here I am removing sine inverse, means I am writing that simple trigonometric function. Sine inverse x I am taking on the other side, and then take reciprocal on both sides. By taking reciprocal, we are getting 1 upon sine y, which is equal to 1 upon x. And 1 upon sine y is cosec y. And then we are shifting cosec on the other side, that will become inverse. And then cosec inverse 1 by x is y, and y is sine inverse x. Therefore, what we are getting, sine inverse x is cosec inverse 1 by x. Similarly, we can prove these inverse trigonometric functions relations. This you can try yourself. Now let us discuss next property, and which is sine inverse minus x equal to minus sine inverse x. Here again we can consider either LHS or RHS as y. I am taking LHS as y, then remove inverse function. It will become sine y as minus x. Then multiply both the sides with minus 1, because we want to remove this minus sign. And then we are getting minus sine y as x. And we know that sine of minus theta is minus sine theta. That's why we can write sine of minus y as minus sine y. And this x is as it is. Now let us shift this sign on the other side, that will become inverse. And then multiplying both the sides with minus 1, we are getting here y as minus sine inverse x. And why we have chosen sine inverse of minus x, that's why what we can write, sine inverse of minus x is equal to minus sine inverse x. On the basis of it, we can prove these two. Tan inverse of minus x is minus tan inverse x, and cosec inverse of minus x is minus cosec inverse x. These two are exactly same. You try yourself. Now next property is fourth one, which is cos inverse of minus x is equal to pi minus cos inverse x. And here again we are taking LHS is y, and y is cos inverse minus x. Then cos inverse we are taking on the other side. It will become cos y as minus x. Multiplying both sides with minus 1, and we are getting minus cos y is x. But what we know, cos of 180 minus theta is minus cos theta. That's why we are writing is cos 180 means pi. Cos pi minus y is minus cos pi. And then what we are doing, again we are shifting cos here. It will become cos inverse x. And then what we are doing, we are shifting cos inverse x on this side, and y is taking other side, and y we have chosen as cos inverse of minus x. That's why what we have proved, cos inverse of minus x is equal to pi minus cos inverse x. Similarly, we can prove these two properties on the basis of it. You try yourself. Means by taking these relations, by taking all these steps, you can prove these two yourself and these two yourself. Now let us discuss next one, and which is sin inverse x plus cos inverse x is equal to pi by 2. Here, y is sin inverse x. We are taking either of the two as y. Then let us remove this inverse function, which is sin y as x. And then sin theta can be written as cos 90 minus theta. Cos 90 minus theta is sin theta, and 90 is pi by 2. That's why we are writing cos pi by 2 minus y as x. Then pi by 2 minus y as cos inverse x. And then what we are doing, we are taking y on the other side, and y is sin inverse x. That's why what we are getting, sin inverse x plus cos inverse x is pi by 2. Similarly, we can prove these two. That is tan inverse x plus cot inverse x is pi by 2, and secant inverse x plus cosec inverse x is pi by 2. Now let us discuss the next one, which is sin inverse x plus sin inverse y is equal to sin inverse of x square root of 1 minus y square plus y into square root of 1 minus x square. Here we are having two variables, x and y. That's why we have to choose both of them as a or b. That's why what we are taking, this is as a and this is as b. Now let us remove inverse function. We can write x as sin a and y as sin b. On the right hand side, we can replace x and y, x as sin a and y as sin b. After replacing it, we are getting it. And then 1 minus sin square b is cos square b, whose root is cos b. And 1 minus sin square is cos square a, which is cos a. And therefore, sin a cos b plus sin b cos a is a formula of sin a plus b. And already you have done in first property, that is sine and sine inverse. If they are together, then what is left? Only a plus b, and a we have taken as sine inverse x and b is sine inverse y. Means RHS equal to LHS, and this property is also proved. On the basis of it, you can prove many more. Let us see. That is cos inverse x plus cos inverse y as cos inverse of xy minus square root of 1 minus x square root of 1 minus y square. Cos inverse x minus cos inverse y is equal to cos inverse of x into y plus square root of 1 minus x square root of 1 minus y square. In both the cases, you have to follow the same rule. This you have to take it as a and write it as b, and then same process which you have followed in property number 6. These two you try yourself, and then you can see in case of tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy. Here x into y is less than 1 because x into y should be less than 1 because there is minus sign. 1 minus any number should be less than 1 because it will be positive. Process is same. Take it as a and it as y. Then we can write it as x as tan a and y as tan b. Then on the right hand side, replace x as tan a and y as tan b. It is a formula of tan a plus tan b upon 1 minus tan a tan b is a formula of tan a plus b. And you know tan inverse are together. That's why what is left? A plus b, and a is tan inverse x and b is tan inverse y. It means by taking RHS, we are getting LHS and both are equal. This is proved. Similarly, you can prove tan inverse x minus tan inverse y by taking same process, tan inverse x as a and it as y. But you should learn if x into y is greater than 1, then tan inverse x plus tan inverse y will be pi plus tan inverse x plus y upon 1 minus xy. Right? Then you try yourself on the basis of it. Now, next is x is equal to sin inverse 2x upon 1 plus x square. Here, let us take it tan inverse x as y, then x can be written as tan y, and then replace on the RHS x as tan y. It will become 2 tan y upon 1 plus tan square y, which is a formula of sine 2y. Then sine and sine inverse are together. That's why 2y is left and y is tan inverse x. Therefore, again, By taking RHS, we are getting LHS, and hence it is proved. On the basis of them, you can try these yourself. And one I have solved, which is the last one, in which I am taking cos inverse x as y, and then x as cos y. By taking it on the RHS, x as cos y, and then what we are getting, 1 minus cos square y is sin y. It is a formula of sin 2y and sin inverse together. That's why 2y is left and y is replaced as cos inverse x. So in this way, the same process you can follow here. You can take it as y, sin inverse x as y. Here you can take it as tan inverse x as y and tan inverse x as y. You try these properties yourself and learn them properly, because you can use these properties in solving the questions also. Thank you so much, and we will meet again and revise them properly, because you can solve many more questions based on them. Thank you so much and goodbye.